In this video, I'm going to introduce some common ions that will be useful in what we call nomenclature or naming ionic compounds. So we see table 2.4 here, which lists some common cations up top here. And we have our +1 charge cations. So these are all the group 1 metals, including also the silver ion. So silver forms one ion and it has a +1 charge. So it's listed in this grouping here. Then we have some common +2 ions next. So these are all the group 2 metals. And then we also see zinc and cadmium. So zinc here is bolded. This only forms a +2 ion. There's no other species possible. So we have our +2, our +1 common ions. Then we go over here and we see a polyatomic ion here, ammonium. So the ammonium ion, that's really the only polyatomic cation. Besides, we may see hydronium rarely, but we'll write this here as well, hydronium. So we generally have only +1 charge monoatomic ions, and then this one polyatomic. So we also have some common charged or transition metals that fall into these categories. So we can see copper has both a common +1 ion up above and a common +2 ion. So just be careful that you designate the right charge, that it's a copper 1 or copper 2, or in some cases, we have iron 2 and iron 3. So make sure that when you combine charges to form your subscripts, you have the right species. Then down here we have some common anions. So I'll point out a few that you should know. So we have our halogens. We have the cyanide, Cn ion, and then the hydroxide ion here. I would also know the polyatomic acetate ion formula, perchlorate here, ClO4, and nitrate. In addition to those, we also have some -2 charged ions that are polyatomic, so carbonate and sulfate, those are -2. And then we have one polyatomic -3 phosphate. So the ones that I've highlighted here, I would definitely know. A few others may appear in some of our naming assignments as well. So let's talk about what's referred to as inorganic nomenclature. So these are all the compounds that are either molecular compounds, so all nonmetals. In this case, we're going to begin with inorganic nomenclature for ionic compounds. So we see here that naming, we always write the full name of the cation. So if we have a sodium ion, we would just say sodium in our compound. These are just nomenclatures for the ions listed up here. So we see zinc and then our +3 aluminum ion. So again, these are three common monoatomic ions. We'll also look at some polyatomics as well. And if we have those transition elements, the transition metals that are in the middle of the periodic table, we can't predict their charge because they often have multiple oxidation states, which result in multiple charges that are possible. So I pointed out above iron 2 and iron 3. That's the same over here, but with copper 1 and copper 2, where we have to designate specifically which ion we see with a Roman numeral. So the iron ion, if it's the iron 2, we would use the Roman numeral 2. If it's iron 3, we use the Roman numeral 3. So like so over here with the copper 1 and copper 2 ions. So just remember the transition metals, transition elements, you'll always need a Roman numeral. Lastly, we have with our polyatomic ions, specifically oxyanions of the same element, if there are two possibilities, so say we have NO3 and NO2 for an example here. They both have the same charge. These are oxyanions. This one has an extra oxygen, nitrate. So we would call this nitrate over here, the one with more oxygens. The one with less, we're going to end with ITE. So this is nitrate, R-I-T-E. Here we'll start over. Nitrate, Nitrite. So we can see that the endings indicate less oxygens in this oxoanion. Um, and then we have more oxygens over here. I commonly say that this one ate an extra oxygen to give us nitrate versus nitrate. But we can see this happens in groups of two, sometimes in groups of four. When we have carbon, we only will get one form. So this would be carbonate with three oxygens. But then we can see nitrate would form nitrate as well in group five. We have phosphate that tends to form PO4 with a -3 charge. We can also see sulfate, SO4, and then SO3, 2 negative. This will be sulfite. So as we go through and learn some common nomenclatures, you'll see this trend here that the lower number of oxygens in the oxyanion always has the ITE ending. The higher number has the 8. If we have 4 in a group, we add a prefix in addition to our suffix. So the ending "ite" and "ate" are still used, but to say even more than the less amount, we would add hypo. So if we have a group of, say, 1, 2, and 3 oxygens, all the way over here, we see hypo, and then say it's chlorine, so ClO negative. This will be hypochlorite. Then we have just chlorite here. So you just fill in whatever element, so chlor. This also follows for bromium. So we would have hypobromite and then bromite, and then we have the one that ate the extra oxygen here. So, now we're up to ClO3. This will be chlorate or bromate if it was BrO3. And then when we have one extra oxygen per chlorate, we would call it perchlorate for 4 oxygens here. So we add the prefix per, and then that ending to show the higher number of oxygens, 8. And again, this follows suit for chlorine, for bromine, for iodine. When we have these 4 common ions with the same charge and a varying number of oxygens. So let's take a look at this example here, where we're given, or we're asked, or told rather, that the bromate ion has an analogous formula for the chlorate ion. So we see the chlorate nomenclature above. We want to write the formula for hypobromite ions. So if we follow over here, hypo means that we have lower than the lesser amount. So 2 is the lesser amount. So we would have BrO2, but with 1 less, we would have BrO. We would still have that -1, same charge for all of the ions in that group.